Hello, folks. I switched to English because Zhang, I believe, speaking in English, right? So, Jeff, Pasha, could you please introduce yourself? And let's start with Jeff.
Yeah, sure. Hello, everyone. This is Jeff. So today I going to deliver this talk. This talk is about the Flink plus Zeppelin, the streaming data analytics platform. So I personally like to talk with people and sharing with people. So I'm very appreciative that I have this opportunity to share my last year's experience with you. So I also hope that today you can learn something from me. Yeah, thank you, everyone.
So who will find your talk most useful? What's the expected audience for this?
Yeah, right.
Okay. I believe. Okay, Pasha, introduce yourself, please.
Let me introduce myself. Hi, folks. My name is Pasha. I work at JetBrains for Big Data Tools project. We are building tools for data engineers, and actually we are even building tools to work with Zeppelin. And I hope that in future we will, collaborate with Jeff, and we will be able to build tool better suiting needs ones who want to work with Zeppelin and Flink after this talk, of course. And also, I'm a speaker, and I love to talk on Kotlin, on big data topics, and everything about. Actually, I can give a topic or talk on almost every theme. For example, I gave a topic on Python, how is it viewed by, how is it seen by Java developers.
So, do I understand correctly that you read the chat of this talk in Telegram and you will answer the questions?
Definitely. I'm not sure that I will answer the questions, but at least I'll mark them for myself, and I'll ask them ask Jeff about these questions at the end of the talk.
Yeah, we will have a discussion zone after the talk, and you can ask real question with real big explanation after that. So we have like 5 seconds, and let's switch to the talk. Jeff, you can start.
Okay. So, hello. Thank you. Yeah. Hello, everyone. So I'm Jeff. So today I'm going to talk with you about the Flink plus Zeppelin streaming data analytics platform. First, let me share with you some personal opinions. Because in the I think in my career path, I always work with big data, and I usually when I work in eBay, I would use the big data tools such as the Hadoop and Spark to do some kind of user behavior data analytics. And after that, I joined Pivotal and Hortonworks. At that time, I did some big data infrastructure work, such as work on the open source project like the Apache Test, Apache Levy, Spark, and Zeppelin. So in my opinion, the big data has already been there for more than 10 years. And I think that for the infrastructure layer, it is much mature than before. And you will see that I think the Spark is the best computing engine for the batch scenario, and Flink is the best computing engine for the streaming case, and maybe Kafka is the best tool for the message queue. So I think for the infrastructure layer, it is much mature than before, and I don't think there will be another better engine than Spark at least in the next 5 years. But what is the next biggest topic or the next buzzword? I think the next big thing is about how we can build a platform based on this big data infrastructure to serve the business people, so that they can use these big data tools to solve their business problem more efficiently. So that's why I going to talk with you about the Flink plus Zeppelin, the streaming data analytics platform. Okay. Now here, actually, yes. First, this is my clear brief introduction of my career path. So I think there's two keywords in my career path. The first keyword is the data, and the next keyword is Apache. So in my whole career path, I always work with data, including data processing, the big data tools, the data platform, and etc. And the next thing is about Apache. I would feel lucky that I do contribution in the Apache community very early. Around, I think that my first contribution maybe it's around 10 years ago. So I love open source and I love Apache. So I still believe that the open source is the future of software industry. Okay. Yeah. So here is the today's agenda. So first, I will give you an overview of data analytics, and then I will talk with you Flink and Zeppelin and how we can combine these two Apache projects to build a streaming data analytics platform. And then I will give you a brief demo to show you how that works. And finally is just a summary. Okay. Yeah. First, let's talk about the data analytics. So in my opinion, there's two kinds of data analytics. So the first data analytics is about the historical data analytics. So this is usually about the batch computation. So in this kind of data analytics, usually you will do some computation on batch computation based on the historical data, and do some computation to deliver some static matrix. For example, you would like to know the total page view of yesterday. So this kind of data is historic data, and this matrix is a static matrix. And another kind of data analytics is about the real-time data analytics. So this is about the streaming scenario. And for this scenario, the source data is about the real-time data, and the matrix will be changed over time. So it's dynamic matrix. For example, you would like to know the total page view of the last 1 minute. So that kind of matrix will be changed over time, right? This is a real-time. This is a real-time monitoring and real-time data analysis. Okay. So what is required? What is required for the streaming data analytics? Because this is today. This is my focus of this today talk. So what is required for streaming for building a streaming data analytics platform? I think there's two key things. The first thing is that we need a streaming engine, right? And the second thing is that we need an analytics platform, to upon the streaming engine. So here, what I propose or what I used in the last 1 or 2 years is Flink plus Zeppelin. Flink is the use Flink as the streaming engine, and use Zeppelin as the analytics platform. So yeah, so let me first give you a brief introduction of Flink and Zeppelin. So what is Flink? First, Flink is the Apache project. It is a framework and the distributed processing engine for stage 4 computation over unbounded and bounded data stream. So here is diagram about the overall architecture of the Apache Flink. So on the right side, you can see the source data. The source data could be transaction or logs or data from the IoT devices, or it could be the clicks events. And these kind of events will fit into the Flink computation engine, and the Flink will do some computation on these data, and then it will store data in some third-party things. It could be some other kind of application, or it could be in a database or file system or KV store. So this is a very typical architecture and usage scenario of the Apache Flink. And so how can we use Flink? Basically, there's 4 programming languages that you can use. First is Java, and Scala, and Python, and SQL. So for a lot of
So we have some problems with our connection. Pasha, are you here?
Yeah, I'm here.
So
can I hear me well?
What do you think so far? What about?
Well, currently we found some, basic information about how can be Flink used. Well, it may be a good starter for someone who didn't use it and even didn't read it. I'm looking forward to find new thing, and actually looking forward to find how to use Zeppelin and Flink in the best way. Because for me, it's quite interesting. Because for me, Zeppelin is tool for basically exploratory data analysis, and we can't tell the same about Flink, because Flink is about streaming. So how do these two things live together? And the most interesting question: how should we, productize the thing? Okay, I wrote some code, with Flink in Zeppelin. Okay, I've pressed Shift plus Enter hotkey, and it's running. Okay, it's streaming something. How should I view results, and how should I, deploy it to production? Or should I, well, in machine learning, there are some ways, but for example, Netflix built the whole technical stack to publish the Jupyter notebooks into the cloud, into the production. They have added some scheduling there, and lots of another, wrappers around standard Jupyter to allow the data scientists to post, just ready Jupyter notebook to production. But I'm not sure that Zeppelin has same abilities as Jupyter in Netflix.
So what do you think? If I pick just distribution of Zeppelin and then containerize it and run it on Kubernetes at just everything else, does it work?
Well, of course it will work. But we'll still have to solve several problems. For example, how to, make this job actually running, and how to monitor it. I'm not sure that every job has monitoring abilities. Maybe Jeff will say something about it actually in his talk. And what else is interesting is that Zeppelin runs lots of other things, but not only the thing you need. For example, it runs not only your Flink task, it runs the whole Zeppelin jar, which is not actually needed for your task to work in production, and it's quite heavyweight.
So is it possible to refactor your application out of Zeppelin inside a separate job and run it separately? What do you think?
Maybe. And I would like to hear about it from Jeff, because actually, what can stop me? Of course, I can, copy paste code and paste it into, like my IDE. I hope that it's Big Data Tools IDE or Big Data IDE, of course. And then, pack it some way, like we package our Spark applications into fat jar, and then just submit it to Hadoop cluster or anything else, Kubernetes and so on. And hopefully it will run. But my question is, what is the role of Zeppelin here? I still don't know.
But if you use some Zeppelin APIs in your job, like Z functions, z.show, etc., it will not work, right? You should remove these lines before compiling and running it on Hadoop.
Sounds like that is true. Of course, I can, add Zeppelin jar and add my Z to my context, but it will look strange. And actually, I don't need this pretty visualizations in my production as usually.
Yeah, but removing the visualizations, English, so I cannot pronounce the word visualizations. So you have to do some work to remove these lines. And if you have thousands of lines, it will become a big job, right?
Yes, but we have such thing like structural search and replace in IDEA, IntelliJ IDEA. You can pass something pretty sophisticated there that find me all instances of Z and all the methods calls on the Z, and just remove the statements. Maybe it will work.
What about other things like runtime requirements, etc.? Is it only Z, or maybe some things about parallel execution, synchronizations of jobs, etc.?
Repeat, please.
Mm-hmm.
Sorry, guys. Yeah, my network issue. So let me continue. So here's a diagram about the overall.
I need to ask you to rewind a couple of slides before, because you obviously skip it because of network error.
Okay, so which slides should I go back?
Just a couple, just like 2.
Here?
Yeah. Yep.
Oh.
Here we go.
Okay. So yeah.
And we have lost Jeff again.
Yeah. So unstable connection. Just to say, it's not about Russian connection, right? It is outside somewhere in China, something like that. Yeah. So we cannot do anything with that. We can actually connect with mobile phone maybe, but it is too hard for this. And Jeff really needs slides and screen sharing for the demo. So let's continue. You wanted to containerize everything inside Zeppelin, right?
Yeah, and your last question, if I understood this correctly, was about other dependencies but Z. Zeppelin. Well, we know that there is API in Zeppelin which allows us to get some useful variables from Zeppelin. For example, our Z tools and big data tools work some tricky way by sending special comment to Zeppelin, and it gives back all the variables he knows right now. And there is a way to ask Zeppelin to give us all dependencies of interpreter, and we can assume that this dependencies will be enough to run any application. Any application when we are speaking about the situation when we have deleted everything Zeppelin specific.
Actually, you are talking about Z-Tools. It's an open source project, right? But for me, it sounds like a crazy hack. The hack is that we got our notebook and then put a virtual paragraph on the top of it and run it every single time. And on the Zeppelin side, we run a Scala interpreter and asking what the local variables is, etc., and then send it back to the results of this virtual paragraph and parse it with anything we need, like ID, console, external libraries, etc. But maybe we just need to add this functionality to Zeppelin itself, because everything about the tools sounds like a really crazy hack.
Yeah. Well, I'm not sure about crazy. It's what developers do all the time. So I can see Jeff again.
Yeah, hi Jeff.
Are we able to start?
Yeah, hi.
Jeff.
I'm sorry that it's due to my network issue. So can you see my screen now?
We see your face a bit. Now we can see you.
Okay,
Yeah.
cool. So now let me continue. So so that's why I'd like to introduce you with the Apache Zeppelin. So what is Apache Zeppelin? Zeppelin is a web-based notebook that can enable data-driven interactive data analytics, and you can use Zeppelin for collaborative documents with SQL, Scala, Python, and more. And here on the right side, I have a screenshot of the Zeppelin. You can see that you can write code in Zeppelin and run the code, and you can get the results interactively. And actually, you can visualize the results in different charts. So here is a basic architecture diagram of Apache Zeppelin. Basically, it consists of 3 layers. On the right side, on the left side, it's about the client layer. And in the middle, it's about the Zeppelin server. And the client layer will can communicate with the Zeppelin server via the WebSocket or REST API. And the Zeppelin server actually is a web server that can serve requests from the client. And its responsibility including the notebook manager, interpreter launcher, and interpreter manager. And on the right side, it's about the interpreter part. So actually, Zeppelin support. So the interpreter part is a pluggable component. So for now, Zeppelin supports most of the popular big data tools such as Flink, Spark, Hive, Presto, Impala. So and the Zeppelin server can communicate with the interpreter via the RPC. So this is a basic diagram, a basic architecture of the Zeppelin. And now let me introduce the basic idea of the Flink on Zeppelin. So actually, Flink on Zeppelin is that means the Flink interpret in the Zeppelin. And here in the left side is the is about the diagram about Flink interpret. And internally, we will run 2 basic components: the Scala shell and the Python shell in the Flink interpret. The Scala shell is used for to run the Scala code, and the Python shell is used to run the Python code. So the Scala and the Python will share the same execution environment and string execution environment and table environment. Actually, these environment variables are the basic entry point of the Flink program. And on the right side, it's about the job manager. The job manager means the Flink cluster. So the Flink interpret will submit Flink job to the job manager, and the the Flink cluster is used to managing the life cycle of the Flink job, and the Flink interpret is used to submit the Flink job. Okay, now let's go to next slides. So here I will give you a brief introduction about the main features of the Flink on Zeppelin. So basically, there's 6 main features. The first is about the multiple language support. You can write different languages, including the Scala, Python, SQL in Zeppelin to run Flink job. And the second thing is about the multiple execution model. That means actually we know that Flink supports different execution model, like the standalone cluster, the Young cluster, and the Kubernetes cluster. So in Zeppelin, we support this kind of execution model. And the next thing is about the Hive integration. So you can use the Hive very easily in Zeppelin, just by some very simple configuration. And the third thing is about the third-party dependency management. So usually when we write or run Flink job, we will have a lot of dependency. For example, you would like to read or write data to Kafka. So in that case, you need the Kafka dependency, right? So how can we do that in Zeppelin? Actually, it is pretty easy. I will, in the next few slides, I will talk about that. And the next thing about the advanced job control, you can not only you can just submit job, but you can also cancel a job. You can also change the job parameter and etc. Yeah. So the last thing is about the streaming data visualization. So personally, I think that this is very maybe this is very most important feature of Flink on Zeppelin, because this kind of feature can allow you to visualize the streaming data very easily. So usually, actually, I'm a backend engineer, and I just have some very basic knowledge of front end. So if you would like me to write some web application to show some streaming data, that would be very difficult work. But in Zeppelin, you can just visualize the streaming data very easily without writing any HTML or JavaScript code. Yeah. So now let me just go deep into each feature one by one. So the first thing is about multiple language support. Like I said, there's 3 main languages that is supported in Flink on Zeppelin. So Scala, Python, and SQL. And the most important thing is that not only you can write different languages, but also that you can collaborate with these different languages, because these languages, they share the same thing. They share the execution environment, the string execution environment, and the table environment, and the catalog. So that means you can use the multiple language in one Flink cluster, and you can do some cross-language operation. For example, you can share UDF cross the language, and you can share the table cross language. For example, you can write Flink UDF in Python language, and then you can use that UDF in SQL and in Scala, and vice versa. You can write UDF in the Scala language, and you can use that UDF in SQL and Python. So here the Python means the PyFlink, right? And the next thing is about shared tables. That means you can create a table in Python, and then you can use that table in SQL or Scala. Yeah. So the next thing is about the multiple execution model support. So basically, for now there's 3 different execution models that is supported in Flink on Zeppelin: local model, remote model, and Young model. And the Kubernetes support is still not implemented yet, but we are working on that. I hope that we can you can use that in pretty soon. Yeah. So the next thing is about the third-party dependency management. So we all know that in the real world, in a very typical Flink job, you will have lots of dependencies, right? So if you would like to use some dependency, if you just use IDE like IntelliJ, you can specify the IntelliJ via the pom.xml if you are using Maven, right? But how can we do that in Zeppelin? Zeppelin is a notebook. How can we specify the third-party dependency? So actually, it is very simple. So here we have 2 options. First is via the flink.execution.packages. So for this property, you just need to specify the dependency packages. For example, here I just show you one example. For example, here you just specify the Kafka dependencies, right? And the Zeppelin will download these dependencies for you automatically and put them in the class path. And the next option is via the flink.execution.jars. So for this property, this option is used in the case that when you cannot, you do not have internet access, so that you cannot download these dependencies. So, but in that scenario, you can just specify the jars. So you can download them by yourself and put them on the machine, and it just specifies the absolute path about all these jars. So here I just build the Kafka jar and specify the jar path in here. Okay, so this is 2 different ways to for the third-party dependency management. So the next thing is about the advanced job control. So in the Flink, you can submit job, you can configure job, and you can monitor the job, and you can cancel the job. The last thing is that you can also resume the job from same point or from the checkpoint. And actually, I will show you how do this kind of operation in the demo part. Okay, now I will show you the streaming visualization. So basically, there's 3 different of visualization that that is supported in Zeppelin. That is a single model, Append Model, and Append Model. So now let me show you one by one. So first is about the single model. So the single model means that it is HTML. So this is for the case that it is a single row result. Oh, I'm sorry that because my presentation is converted to PDF, so now you cannot see the animation. But don't worry, I will show you the demo later. Yeah, you can see the you can see the animation later. So so this is for the single row result, and the output will be a HTML format. For example, here we have an example that we select max and count from a sync Kafka. So so we can see that for this kind of SQL, it will always be a single row, right? And but the result will be refreshed over time. So actually, you can see you can HTML output here, and it updates over time. So the next next model is about Append Model. So this model is used for the when your SQL result is multiple loads. So for example, here we have a SQL statement that it is group by. Right? Here is group by status, and you can see that for this kind of SQL, your data will be refreshed over time, and the new data will override the previous results. And for this kind of model, we call it is Append Model. And you can see, actually, in the demo part, you will see that this kind of bar chart is updated automatically. And the last thing is about streaming visualization. So streaming, it's Append Model. So the Append Model is used for the scenario that you have output data, and you have new output data, and this output data is always appended to the previous results. For example, here is a SQL statement that it will group the data by a time window. So for this kind of SQL, you will always have new data appended, and this kind of data won't override the previous result. It will just append it to the previous result. So yeah, this is the Append Model. Now, the next thing I'd like to talk with you is about the Zeppelin SDK. So I think that maybe most people know Zeppelin, and they will think that Zeppelin is a notebook, and it is used for the interactive development. But actually, Zeppelin is not only an interactive notebook. It could also be used as a general job server, which you can submit any kind of jobs, such as Flink job, Spark job, or Hive job. And you can just actually you submit job. You can submit this job via the Zeppelin SDK. So basically, there's two ways to use the Zeppelin SDK. The first is about the Zeppelin client, and the second about the Z session. And now let me give you a brief introduction about the Zeppelin client. So Zeppelin client is the low-level API that can that kind of API is need to create note or paragraph explicitly. So here is the code snippet, and in this code snippet, first you need to create the client config. The client config including the information about the Zeppelin, such as the Zeppelin URL here, and you can use that client config to create a Zeppelin client. And the Zeppelin client is the entry point of the Zeppelin. You can use the Zeppelin client to create a node and add a paragraph. The code is in the paragraph line. You can execute the paragraph. Execute the paragraph means execute the code in the paragraph. So here you can, it will execute the Python code here, and you can get the result. And after you get the result, you can do whatever about the result. You can display it. You can display it in the front end, or you can store that in some database. You can do whatever you need to do. So this is Zeppelin client. The next thing is about the Z session. The Z session is a high-level API, and in these sessions, there's no concept of the notebook paragraph. So so you don't need to create node paragraph explicitly. For example, here you can create a Z session. First, you need to specify the client config and specify the interpret that you need to use. Here, I specify the Flink, and you can also specify the interpret properties. And after that, you can just submit code to this session. For example, I just submit Flink SQL here, and you can get the result. And actually you can do whatever you would like to about the result. Yeah. So actually, in the demo part, I will just show you some real examples, and you can just get an intuitive impression about what it is the Zeppelin SDK. Yeah. So this is now it's a demo time. Let me show you some demo. Actually, let me. Sorry. Okay. All right. So here it is the Zeppelin, and let me sorry. And first, let me show you how to configure the Flink. So here, first you can go to the interpret menu, and after you get into the interpreter page, you can configure the interpreter. For example, here I can configure the Flink home. So basically, the only thing you need to do to configure Flink is about the Flink home. If you would like to use Flink in Zeppelin, and after that, you can use the basic function of Flink on Zeppelin. But if you need to use other features, such as you would like to use the Flink on Yang, or you would like to use Flink with Hive, so you need some other configurations. But for now, just for this demo, I just need to launch in the local mode. So I just need to configure the Flink home. So here I use the Flink 1.11. And now let's get back to the Node page. And here I will show you some basic examples. So here I will write some Flink Scala code. So in this Flink Scala code, I will add a customer source function. And in this source function, I will simulate some data. This kind of data is about some web access logs. So I simulate, so for example, here we have 3 kind of pages: home page, the search page, and a product page. And we will simulate these kind of access logs. And after that, we will register that data string as a Flink table. So the table name is log, and the 2 fields, time and URL, right? So now let me launch. Okay, it is running. So usually, because for this demo, I launch in the local mode, so it will launch a mini cluster for the mini cluster for this demo. So it will be in the first run. It will be a little slow. It will take some time to starting the mini cluster. Yeah. Okay. Yeah, we can. So when you run the program, you can see the output of the program, just like what you see in the Scala shell. So now, okay, now it is done, right? And you can see the results finished. Okay. Now let's run a SQL statement over this log table. So now I'd like to get the page view of each page, right? So we need to group by the URL, actually group by the page type. So now let me launch. Yeah. Okay. Now you can see that the bar chart is displayed, right? And it is refresh automatically, you can see the number here is changed over time, right? So that means the Flink job is started and the date is generated over time. And here we have
Okay.
I believe we have
now
some connection issues again.
But now we have graphs in our
sorry?
demo. Yep. Let's continue.
Okay. So besides that, you can also cancel a job here. For example, if you click that button, you can cancel a job. Right? The job is aborted. And if you go to the Flink web, you can see that the job is canceled. Right? Okay. Now let me show.
Jeff, your Zoom is down. Please restart Zoom.
Zoom is down. Okay.
Yeah.
No.
So
we need your slides. So please restart. Zoom.
Jeff's demo. We actually need Jeff's demo. Demo is the most interesting part.
Yep.
Yeah.
Here we go again.
Okay,
yep.
Cool. Okay, so let me continue. So just now I show you how to submit a Flink SQL job and cancel that job. Now let me show you another example. This example is the same thing, but with some additional configuration. You can see here that we have several other configuration. For example, the parallelism, max parallelism, and save point, and whether you need to resume from the same point. So for example, let me first let me set the parallelism as 1, and let me run this Flink job. Okay, so you can see that this Flink job is starting. And actually, you can notice that the PV value here is not starting from the 0. It is from, actually, because I run this job before. So when this job is run again, it will starting from the same point. It will not start from the very beginning point, the 0. So now I will do operation. I will do as one thing. First, I will cancel the job and change the parallelism. For example, so first let me show you the Flink web UI. So here we will see that the parallelism is 1, right? But usually the change of parallelism is a very typical operation for people. For example, you have one Flink job that is with parallelism of 1, and over time you feel that you have a lot of traffic. In that case, you want to update the parallelism to increase the parallelism. So in that case, you can cancel the job and change the parallelism and continue restart your job. So you can do it very easily in Zeppelin. For example, let me cancel that. Okay, now it should cancel, right? Let me change the parallelism as 2 and run it again. Okay, yeah, it is started, right? And you can see the PV value here. It is not starting from 0. It will start from the last same point. And let's check the parallelism. Okay, let me zoom in. Yeah, you can see the parallelism, right? It changed to 2, right? So that means the parallelism is updated. Okay, so this is how we can change the parallelism and resume the job from the same point. Let me cancel that again. And here I have 2 other examples. So just now I show you how to run the job by Flink SQL. Actually, besides that, you can run your job also by Scala or Python. For example, here it is a Scala program. let me launch again. And here it is a Python program, and I can also launch. So in Scala, you can use the C.shu, and in Python, you can also use C.shu. This is a utility function that is provided by Zeppelin. You can use that function to visualize the Flink table in Zeppelin, right? Yeah, here you can see the results. Actually, now the result is displayed in table format. Actually, you can use bar chart, pie chart, error chart, line chart, and scatter chart. So whatever chart you can choose. Yeah, here this is the Python. Yeah, this is the Python streaming job. Yeah. Okay, so this is how this is the demo that I would like to show you how to run Flink job interactively in Flink, in Zeppelin. Sorry. So next, I would like to show you the how to run Flink job by the SDK. So here I will show you the Z-session example. For example, here it's in the Z-session example. I will first I need to create the client config. The client config means that I think I forget one thing because I need to yeah. The thing is that I need to restart. Yeah. The reason I need to restart the interpreter is because in the local mode, the Flink mini class will use port 8081, and if that means I can only start one mini cluster in my laptop. I cannot start another mini cluster. That means if I run this program, I will get some errors. So that's why I need to stop it first. So here it is a program about the how to use this session to call run Flink job. So here I use the Zeppelin build, this session build to build the session, and then I can start this session with some composite method handler. So the composite method handler is a very special interface that is used to capture the streaming data. For example, here it is the implementation. Sorry, actually I have. Let me. Yeah, actually I have two different statement method handlers. This is my statement method handler 1. So in this statement method, I just print out the data. So that means in the IDE I just print out data, but in the Zeppelin, it will update the front end. It will refresh the data in the front end. So this is the difference. So this interface is just allow you to do whatever operations that you need to do on the streaming output. So yeah, this is the so in this example, I also do the same thing. I will run this SQL statement. This is group by the URL. Yes, this is to get the p value, and I will just print the result by the my statement method handler 1. And let me run this program. Yeah, it will just take some time. Right. Okay. Like the demo I did it in the Zeppelin UI. It will so the first run it will launch the Flink local mini cluster. So it will just take a little bit longer. Yeah, just wait for a few seconds. Yeah, actually, underneath this session API, it will actually create a notebook in the Zeppelin. Oh, sorry, it's broken. Wait, time out. Yeah, I maybe I got things because I opened some VPN, so maybe it's a network issue. But yeah, so I don't want to waste time here to make this demo work again. So my time, I think my time is limited. So yeah, let me go ahead with my slides. So yeah, so this is the demo I did, and now I just give you a summary of my today's talk. So today I give you an overview of the data analytics. It's about the two kinds of data analytics. One is the historical data analytics for the batch scenario, and the second is about the real-time data analytics. It's about the streaming scenario. And then I introduce you with Flink, the streaming engine, and the Zeppelin, the analytics tool. So there's several basic features of Zeppelin. You can use multiple languages, multiple execution model, and third-party dependency management, and advanced job control, and the streaming visualization. And after that, I just give you a demo. So because there's a lot of content in the about Flink on Zeppelin, so I cannot cover everything in today's talk. So I just give you several links for more details, and you can check these links for more details. Okay, thank you everyone. Yeah, I hope you can you like my talk and can learn something from me. Thank you everyone.
Thank you, Jeff. It was quite interesting. I found lots of interesting things for me. Let me ask you for something that is in our attendees chat. Give me a minute, please. Our question is, Sasha is asking, hi, can you advise any useful links to read about PyFlink, etc.? I'm starting development of sources and things and looking for all helpful links and examples. Thanks.
Sorry, I didn't hear you clearly. It's about the
actually,
right?
it's the question about best sources to learn about PyFlink, etc.
Oh, best resource to learn PyFlink. I think the best resource is the official Flink website. Yeah, and if you and the next resource is that you can, if you have any question, you can ask in the Flink user mail list, and there's a lot of people there can help answer your questions. Yeah.
Oh, cool. So there is no books like mailing likes to publish Flink connection and so on.
Yeah, I don't think there's any books officially. I know there's one book about Flink, but it is maybe it's about Flink 1.7. So at that time, there's no PyFlink. So the best, I think the best thing to learn PyFlink is still the official Flink website.
Okay, that's quite interesting. How do you think? Why does Spark has quite a lot of books written about it, and Flink doesn't?
Sorry, what's the question about compare Spark with Flink?
Spark has there are lots of books about Spark, Spark and Hadoop, and Spark and Action, and so on. And there are, as you said, almost no books about Flink. How do you explain that?
Yes, I would like to say that yes, Spark is popular.
Have some problems with audio. Pasha, can you hear me?
Yeah,
I can hear you, Oleg. And I can hear Jeff too, actually. Can you hear Jeff?
Okay, so yeah, let me continue. So Spark is much more popular than Flink because the Spark's main scenario is the batch computation, and the Flink's main scenario is streaming computation, and of course the batch computation is much.
Jeff, we have lost you.
So,
hello?
Yeah, I can hear Pasha. Like Jeff is trying to say that competition is too high, right, from other technologies.
Yeah, I think he's trying to say that batch processing is much more popular than stream processing, and it's quite interesting point because I don't know why. For me, stream processing looks more natural and simple. Well, of course, when we are speaking about things like SQL on streams, it sounds weird, but when we are speaking about just pipe which transforms data from some source to some sink, it sounds absolutely natural. Change something in this data and this change one more thing and one more thing and then put it into some destination. It looks natural. For example, when I've been working at LaModa, we have been we have built a pipeline over Kafka, and we have used Spark structured streaming, Spark streaming for it, and it's quite weird solution because it's not real streaming. You're just getting very small micro batches of data, and then you're transforming it, and then you're writing it to some destination. And I couldn't understand why didn't we use streaming for Kafka. And actually, Kafka has streaming built into itself. It's called, surprise, surprise, Kafka Streams. Well, lots of data engineers don't like Kafka Streams, and Kafka Streams has some limitations. For example, you cannot replay your history from the random point in time. But still, why don't we use streaming when we are reading something from Kafka? I can't understand that. And the same is about Dependency. When we are reading write-ahead logs from relational databases in almost real time, we could stream them, and we don't do that. I don't know why.
So what about exploratory data analysis and maybe machine learning parts? Because people like things like Zeppelin or Jupyter Notebook, etc. And do you think that streaming model fits into model of interactive notebooks?
Well, in this presentation, Jeff has shown us that it could be used. Definitely could be used. It was surprising for me, actually. I didn't know that Zeppelin can build charts over streaming data, but it looks quite nice. I would say that it looks even better than Spark visualization, because Spark visualization is static, and here we can change something and can see that okay, now our chart looks another way. And then when stream comes, when stream updates our data, we can update our visualization. Still, well, yeah, it updates our visualization, and that's enough. Still, I don't understand how to productivize this thing. Of course, the second demo of Jeff was about that session, that we can submit, any random code to be executed to Flink, to Zeppelin cluster or to Zeppelin instance, but I'm not sure that it's comfortable way to develop programs, because you're creating some that session, you're submitting some calls written by strings there, and you should handle data updates automatically. For example, in the second demo, there should have come out, some count is updated, some another data is updated. I don't remember actually what columns were requested there.
So, but Zeppelin is open source solution, so actually we can go and refactor it a bit to run everything in a non-interactive way, and this problem is just gone after it automatically.
But do we really need it? Of course we can. There is famous Russian picture about loaf of bread, which says that this way we can build a trolley bus from bread and something else. But why? So yeah, but why? I believe that Flink jobs should run separately from Zeppelin inside Kubernetes cluster, Yarn, or whatever resource manager.
The other thing that we actually have no books about this, have no good resources, and we need to go to the conference to see this. Why?
Well, it's good. If I understood Jeff correctly, the documentation for Flink is quite extensive. So
it's not about extensivity. Like documentations for C++ is extensive too. It's big, huge, so huge that no one can read it actually in 2020. It's about common practices, how to do big data, how to do analysis, how to productivize it, etc.
Yeah, and I still have these questions. I have some ideas on productivizing, but I will try to ask Jeff in discussion zone. For me, it's a really interesting question. Is Zeppelin the best way to productivize Flink jobs? Should we productivize Zeppelin itself? Should we productivize Flink jobs separately? Should we write our own handlers like he did for data update? And if we, for example, we have built our own handler, it's quite simple, as we could see in code. So where should this data go from this handler? To another Flink, or to Kafka, or to Prometheus? It's not that easy to say for me. I believe that data which we can gain automatically from some Flink query should go to some storage. But should it be aggregated data? I think no, because I'm not even sure that Flink is good, nice tool for. Oops, I've lost my idea. For complex aggregation and writing of aggregated data. But maybe I'm wrong. Maybe I'm wrong. For example, if we are trying to build some charts, scatter charts, and so on, maybe Flink is the tool of your choice.
So maybe we just can provide an abstract interface, abstract enough that every consumer can choose by themselves how they want to use it.
And what's interesting, we have such interface, it's called Apache Beam, and there will be a talk on this conference by Neville Lee about the data platform they have built on Apache Beam, and Apache Beam can work both on Spark, as upper level. It can execute its queries on Spark and Flink. So we have such an API, and it's quite interesting. And Shia, which is built on Apache Beam, is even more interesting for me.
Like I know at least a single application where I can use it personally. For example, if you can streaming data and I want to create a landing site or some charts that I want to share with my boss or with my community, it would be nice to stream it directly to this page and forget about every obstacle in the front of me.
But do you really need Flink for that? Maybe it will be enough for you to, save updated data once an hour and then rebuild image with GNU-plot, and that will be fine.
Yeah, it may be enough, but it may be enough like to code in assembly or in C++, but we use Scala instead. So, and streams are very convenient abstraction to do this job.
Enough is a good word, but of course everything is enough. But I would bet that GNU-plot is easier than Flink, and it has lower overhead. It's easier to use, and it's easier to even productivize things which use GNU-plot. We had an episode of our podcast, Новый подкаст 2, where Vanya Ponomarev tells about how do they build static pages with GNU-plot and ASCII-doc, and this sounds pretty impressive. And I think that we have only 1 minute left.
Yeah, we have 1 minute left. So do you think that streaming is much more complex solutions that you just described? Right? Like
Yeah, I believe streaming as concept is very simple, but using streaming in real production may give you some hard times because there are not obvious things. For example, I can't even imagine how JVM works when you stream something with the PyFlink, for example.
JVM, I think it's very hard for. Like we have 30 seconds before switching to our discussion zone, so we need to prepare, and our operators can switch us anytime. So thank you for watching this, and see you in the next block, of talks and videos, etc.
And see you in discussion zone, guys.
Yeah,
Folks.
of course.